Hello, my name is Rui Kurt and I am a part of SocRob at Home team from Instituto Superior Técnico Portugal. The rest of the team can be seen in the bottom of the slide. We are formed by PhD students, master students, and supervised by faculty members. Uh, our aim is to implement our research in real robots and compete in robotic competitions so we can showcase our research in a fun and competitive way. We usually use this robot on the right called Monarch robot, but for RoboCup simulation, we will use Tiago Steele from Pal Robotics. Our functional architecture can be seen here. We will only be using the bottom since we don't need human interaction. We basically use object perception, navigation, and manipulation to complete our goals, combined with task planning. Our object perception is based on DarkNet YOLO. We have two detectors working. We have a generic detector that detects more generic objects we usually see in our environment, like people, chairs, or tables. The specific detector is used depending on the competition. Every competition has a specific data set of objects we need to recognize, and so we train this specific detector for each competition. The detection from YOLO and the information from the depth camera is then used to determine an estimation of the pose of the objects, which is then fed to an extended Kalman filter that outputs the actual pose estimate of the objects throughout time. For navigation, we represent the world through a map that we generate by using FastSlam2. This map is then used also for localization as well as the laser scanner and the odometry by using AMCL algorithm configured to our robots. Then for the navigation planning, we either use the navigation stacks planners like DWA and Dijkstra algorithm, or we use the navigation stack created by a researcher here in ISR that has two modes of navigation, a waypoint navigation based in fast marching method, or a navigation that follows a dynamic goal using a variation of dynamic window approach. For manipulation and grasping, we first obtain the objects from the world through the object perception. Then, according to the object that we want to grab, we first need to determine the grasp pose. We have also research in these fields to grab objects that we do not know a priori. So we try to grab objects, unknown objects, calculating these grasp pose through the point cloud. Then we also have interesting research in using the body as an extra degree of freedom so that the robot is not static while he tries to grab an object and uses its mobile base as an extra degree of freedom. Then, of course, we also use move-it inverse kinematics, and we use visual observing to correct any errors in the object perception or in the arm itself. To generate the tasks, to complete these more elaborate tasks, we need some task coordination. We divide these in these three layers: basic actions that are like rotate the head, perceive this frame, move to this location, simple actions such as these that are then used to create states that are more complex, such as navigate from this point to this point, or perceive this whole scene, or grab this object, place this object, states that are more complex and that are used then to build our state machine. That according with the states and the state transitions, we build a state machine that can accomplish these more elaborate tasks. We can see two of them here on these two videos. One is people following, the other is just grabbing objects, which is not as easy as it looks. In this RoboCup, we will be performing two tasks: clean up and go and get it, where we will be using states that are based in navigation, perception, and manipulation. Thank you.